Hi, Professor Mack here, and this is your 11-4 lesson intro in 5 minutes or less. The major concepts that we're going to look at in this section are angle relationships, transversals, and polygons and angle measures. Angle relationships. The first big thing that you have to understand is the concept of vertical angles. If you look at this diagram, we have angle alpha and angle beta. Those are vertical angles because they're across from one another. There is another set that is not shown within this image, but basically when they're opposite to one another, there's a theorem out there that states that vertical angles are congruent. Vertical angles are created when we have two intersecting lines, rays, or line segments, and it can be any combination of those, but basically those two sets of angles are your two vertical angles, and they are congruent to one another. Then we get into some subset concepts like supplementary angles. A supplementary angle is when you have a set of angles that when their sum equals 180 degrees. And so therefore you have a diagram here where you have 140 and 40 degrees. The sum of those two angles is 180 degrees, so therefore they are supplementary. Then you have the complementary angles. Complementary angles are when you have a sum of angles equaling 90 degrees. So this 60 and 30 equals to 90 degrees. Transversals. A transversal is any line that intersects a combination of line segments, rays, or lines, or like I said, any combination of those. And what happens is when you have that, like for example here where you have line N and line M being intersected by transversal P, you have 8 different angles that are created, and we can actually group those in different ways. First off, we can take angles 5, 6, 4, and 2, and we can make those interior angles because they lie inside of the two lines that are being intersected. Then we have angles 3, 1, 7, and 8. Those are exterior because they lie outside of those two lines that are being intersected. Then we have alternate interior angles. 2 and 5 alternate and they are interior. 4 and 6 alternate, they are interior. And then you have alternate exterior. That's 3 and 8 and 7 and 1. They alternate and they are exterior angles. And finally you have corresponding angles. If you were to imagine taking 4, 2, 7, and 8 and taking those and overlapping them over top of 3, 1, 5, and 6, you would see that those all correspond because those are the spots that would overlap. Now, there is a property that really just kind of changes a lot of the different concepts, and it all comes back to that whole concept of vertical angles. And what it says is if any two distinct coplanar lines are cut by a transversal, then a pair of corresponding angles, alternate interior angles, or alternate exterior angles are congruent if and only if the lines are parallel. So what that means is by having N and M now parallel, transversal P now creates alternate interior angles that are congruent in measure, alternate exterior angles that are congruent, and also corresponding angles that are congruent. And so basically, once again, the huge thing with this parallel lines property is that it only works with parallel lines that are cut by a transversal. Alright, now we get to polygons and angle measures. The sum of the interior angles of a triangle is 180 degrees. And you may know that as a trivial fact, but now that we understand transversals, what we could do is we can take a line that is parallel to XZ and create that where it overlaps where the vertex of angle 1 is. And what we can do is by doing those transversals of YZ being a transversal and YX being a transversal, we can prove that angle 2 is congruent to angle 4 and angle 3 is congruent to angle 5 because those are alternate interior angles. And so what happens is now 4, 1, and 5 all create a straight line, and the sum of a straight line is 180 degrees, so those are all supplementary angles. The next thing that we can do is we can find the sum of the interior angles of any polygon. What we can do is we can break up that polygon into triangles and count the number of triangles. And that actually helps us to create a formula or an equation that allows us to take the number of sides, subtract it by 2, and multiply it by 180. 180, once again, being the sum of the interior angles of a triangle, and that will give us the sum of all the interior angles of any polygon. And then finally, we can also find the sum of exterior angles of any convex polygon. And we'll talk more about what an exterior angle is and get a better understanding of that. But basically, you have all those exterior angles added together. They will equal 360 degrees no matter what convex polygon you have. And that is your 11-4 lesson intro in just a little bit over 5 minutes.